Okay, hello everyone. Our discussion for today is on weight and volume relationships. Of course, in our previous years, we have studied how soil was formed through our geology. Where does it form? What were the grain sizes? So it was studied on geology. Now we move on to soil mechanics, which is we're going to study properties of soil. So to start with our discussion, we're going to move on to weight and volume relationships. So we're going to derive some parameters that is being used in the computation of the certain parameters for the properties of soil that will be useful on the design and analysis of a certain foundation structures. So to start with, before we start with our discussion, let us identify our learning outcomes rather. At the end of this module, the students are expected to explain the weight-volume relationships for soil, including void ratio, porosity, and moisture content. Discuss some relationships between unit weight, void ratio, moisture content, and specific gravity. Discuss the relationships between unit weight, porosity, and moisture content. You have to explain about some other relationships for unit weight. Of course, you have to explain the relative density. You have to explain minimum and maximum void ratios and the factors that affect them. And you have to recognize some correlations relating the median grain size to the minimum and maximum void ratio. And lastly, of course, to assess your learning, you have to compute problems related to weight-volume relationships. So in this chapter, we'll be discussing weight and volume relationship. Of course, for weight and volume relationship, we're going to start with the components or the structure of a soil. So we have a figure. We have an element of soil in which, in this figure, so that we can develop the weight-volume relationship, we have to separate the three phases of the soil, which is solid, water, and air. So if we're going to observe in our figure, you have the illustration. So you have a soil sample. Of course, in this soil sample, we're going to derive parameters. So we have identified here the total weight on the left side. On the right side, we have the total volume. And of course, this is the natural state. This is the natural state of the soil element. So that we can develop the weight-volume relationships, we're going to separate the three phases of the soil element. So we have identified the three phases of the soil sample. We have the air, the water, and the solid. So for that, on the left side, we have here our total weight, which is equivalent to the weight of the water plus the weight of the solid. The weight of the air is negligible. And for the total volume, which is illustrated on the left side of the soil element, we have here volume of the air, volume of the water, and volume of the solid. So for this one, for the volume of the air plus volume of the water, we have your volume of the voids. So it is being denoted as vis-a-vis to represent volume of the voids. So you have to take note of the components or the three phases of the composition of the natural state of our soil element, which are solid, water, and air. And of course, we have to compute basically on our soil element. We have illustrated the total weight, which is equivalent to the weight of the water and the weight of the solid, since weight of the air is negligible. And of course, we have the total volume, which is volume of the air, volume of the water, and the volume of the solid. And volume of the air plus volume of the water is equal to the volume of the voids. So for this one, there are terms that is commonly used. Because we are on weight-volume relationships, we're going to identify the volume relationships, and we have to identify the weight relationships. So for the volume relationships, the commonly used for the three phases and the soil element are, we have your void ratio, we have the porosity, degree of saturation. So meaning to say, there are 3 volume relationships that is commonly used for the 3 phases in the soil element. We have the void ratio, we have the porosity, and of course you have your degree of saturation. So for this one, for the void ratio, it is defined as the ratio of the volume of voids to the volume of the solid. So we have here the formula. Void ratio is equal to V sub V all over V sub S, or void ratio is equal to the volume of the voids over the volume of the solid. For the porosity denoted by N, so it is defined as the ratio of the volume of voids to the total volume. So for the porosity, it is denoted by N, and this is the formula. Volume of the voids over volume of total volume rather. For the degree of saturation, it is denoted by capital letter S, and it is defined as the ratio of the volume of the water to the volume of voids. So for the degree of saturation S, that is equivalent to volume of the water all over volume of the voids. So the relationship between void ratio and porosity, you have this relationship. So we have identified the relationship, we have derived the relationship for our void ratio and the porosity. And we are given with, if we are going to compute for the void ratio, wherein the porosity is given, that is equivalent to N all over 1 minus N. And vice versa, if we are going to compute for the porosity denoted by N, which is equivalent to E all over 1 plus E. So that was the terms commonly used for volume relationships. So the terms that is commonly used for weight relationships are, you have 2. You have the moisture content and the unit weight. So moisture content is also known as water content, and that is defined as the ratio of the weight of the water to the weight of the solid, meaning to say our moisture content is equivalent to weight of the water over weight of the solid. For the unit weight, it is the weight of the soil per unit volume, and that is equivalent to total weight all over total volume. So if the unit weight can also be expressed in terms of the weight of the soil solid, and the moisture content and the total volume, you have this equation. So if you're going to have the relationship, we can have unit weight is equal to weight of the solid multiplied to 1 plus moisture content over total volume. So for soil engineers, sometimes refer to the unit weight is being termed as moist unit weight. So meaning to say, unit weight can also be known as moist unit weight. For example, in a certain problem, you are required to compute for moist unit weight. So when talk about moist unit weight, you are referring to unit weight. So that is the connotation for moist unit weight. So dry unit weight can also be equivalent to weight of the solid over total volume. So you have the dry unit weight is equal to weight of the solid over total volume. So the relationship of unit weight is equivalent dry unit weight and moisture content. So we have here, this is the relationship between the dry unit weight and the moisture content. So our density can be expressed in this form. Density is equal to total mass over total volume. So dry density is equal to mass of the solid over our total volume. So we have also here some relationship for our unit weight, or the moist unit weight, and of course our dry unit weight. So for this one, this is some of the relationship that is commonly used for engineering problems. So that was our discussion for weight and volume relationships. So for this one, we are going to have relationships among unit weight, void ratio, moisture content, specific gravity. So meaning to say, this one are formulas that can be alternative if the weight and volume relationships are not specifically given. So you can resolve your equation through this relationships among unit weight, void ratio, and moisture content. That is dependent on what is given on a certain problem. So basically, you have this illustration, 3 phases of a soil element with volume of solid equal to 1. So for this one, this illustration, it is illustrated on our soil element, wherein you have the total weight, you have the total volume, and it's specified that the weight of the water is given through this equation, weight of the solid is given through this equation, and our volume of the water is given by this expression, and it is being denoted that the volume of the solid is equal to 1. So this is for this illustration, and it was denoted here that the void ratio is equal to the volume of the voids. And basically, the total volume, if we're going to use volume of the solid and the volume of the voids, that would be equivalent to 1 plus E. So that was our relationships among unit weight. This one is the relationships among unit weight, void ratio, moisture content, and specific gravity. This is an alternative formula also, dependent on the given on our certain problem. So we have here different formulas that can be used if the given are not basically the basic formulas or basic data for weight and volume relationship, but still you can resolve that through the given equation. So what is important here is to know the soil element, the 3 phases, the figure, and what is specified and illustrated on the soil element, and you can apply some of the formulas here being stipulated. So here we have our S is equal to 1, so you are given with void ratio is equal to moisture content times specific gravity. This one, saturated soil element with volume of soil solid equal to 1. So yung volume of solid natin is equal to 1. You have the total volume, you are given with the weight of the water, weight of the solid, given with this equation, and you have the volume of the voids, which is equal to the volume of the water, which is equal to void ratio, volume of the solid is equal to 1, and you are given with this specific expression, volume is equal to 1 plus E. So you have here our our illustration for the saturated soil element. So similar unit weight relationships is being illustrated here that will be used for certain problems. You are given with this expression. So that is for additional. This is an additional equation wherein we are given with a soil element showing mass volume relationships. So we're given now with a mass and the volume, meaning to say the relationship between mass and volume. We're given with the mass of the water, mass of the solid given with this expression or equation. Then we have here volume of the voids equal to 1, volume of the solid is equal to 1. So this one is another relationship among unit weight, porosity, and moisture content. So for this one, our porosity is equal to volume of the voids over volume, total volume. So we have here our illustration for the soil element with total volume equal to 1. So we're given also with our weight of the solid given with this expression, weight of the water, you have this expression. So this one, we're given with the weight of the water, weight of the solid with this expression or equation, volume of the void is equal to 1. Volume of the solid is 1 minus n, so we have the total volume is equal to 1. So that is an additional relationship wherein we can be used to solve a certain problem. So for this one, you have here an additional formulas that you're going to utilize to solve a certain problem. This is a saturated soil element with a total volume equal to 1. So we're given here another derivation for certain formulas. So this one is the relationships among unit weight, porosity, and moisture content. So that's our discussion for relationships. So this one is various unit weight relationships. So we are having another several unit weight relationships that can be used for to certain problems. So typical values for void ratio, moisture content, and dry unit weight, which is dependent on the type of the soil. So we have here a certain problem. You're given with a saturated soil. This is derivation. So you are going to show that the saturated unit weight is equal to this expression. So you're going to derive. So make use of the formulas that you have that was stated a while ago. Then try to manipulate so that you can come up with